Okay, hi everyone. What we're going to do in this quick example is demonstrate three different ways to calculate the future value of an annuity. Now, the problem appears right here, okay, in this little block of area here. All right, Alexia Frosch deposits $2,800 a year into her retirement account. If these funds have average earnings of 7% over the 40 years until her retirement, what will be the value of her retirement account? Now, this is the formula right here, and we could calculate this, with a calculator. Now, I'm going to let Excel do a little bit of the heavy lifting for us, but let's drop in what we know. The payment is $2,800. They gave that to us. The interest rate is 7%. That's I. I is the interest rate. N stands for the number of periods, 40 years. So if we were to calculate this using the formula, I've done so right here. Now I'm going to hit the F2. Actually, let me slide this up so you can see this. Okay, I've repositioned it so now you can see the formula. Now, if I put my mouse, click the mouse right on this cell, F13, and hit the F2, you see the exact same thing here as you see up here. So feel free to look whichever way makes the most sense to you. So what we ought to do is work from the inside first. So if we look at the formula, 1 plus I is in parentheses. So let's put that in there, 1 plus I. Well, the value of I is in cell F10. So that's 1 plus 7% or 1.07. Then that caret symbol means raised to the power of n. Okay? And the usual rules of algebra says we do what's in parentheses first and then exponents get handled next. All right, so what's the exponent? The exponent is n. I put that as 40, so it's raised to the power of whatever's in cell F11. F11 is 40. Okay, and then we have to subtract 1 from it, and then I put parentheses around that because we're going to do the entire numerator and then divide it by the denominator. The denominator is given in cell F10, which is the interest rate again. So what do we have? 1 plus 7% raised to the power of 40 minus 1. We calculate that first, then we divide it by 7%. And when we do that, again, this is the formula approach, we get 558,978.31. Now, Excel has a function for this, and this is real easy to do. All right, now, it says Excel function. Let me show you how we could do this. We come into this cell and we would type equal future value, FV. And Excel recognized that as a function. I hit the left parenthesis. Now, what I like to do is come up here and hit this insert function button so that it gives me a pop-up. And then I can just fill this out. Well, where's the rate? The rate is given in that cell. What's the number of periods? The number of periods is given in that cell right there. Okay, what's the payment? Now, this is tricky. I want to point to the payment, but I'm going to enter it as a negative number because the way Excel expects this to work is you give up something to get something in the future. Or another way of thinking about that is point to negative 2,800 as the payment. As we're making the payment, that's a cash outflow to get the cash inflow at a later point. Okay, and calculators work the same way. Now, what's the present value? Well, we don't have anything saved at this point, so we can leave that blank. And these are going to be deposited at the end of every year. We always assume the payments are made at the end of the period, unless they tell us it's made at the beginning. If it's made at the end of the year, it's called an ordinary annuity. If it's made at the beginning, it's called an annuity due. Okay, and we can leave it blank or put a 0. We hit enter, and you see we get the exact same number that we got using the formula approach. So that's the second approach. Now, you could also use a table approach. Now, with the table approach, let me slide this a little bit this way so we can read this a little bit better. Okay, what you want to do is take the future value of an annuity factor from a table, and at this point we have to give it two variables. The interest rate is 7%, the number of period is 40, and you multiply that times the payment. Okay, so to do that, we have to take advantage of a table. And I've got one down here. I'm going to slide this up so you can see it. Okay, now in this problem, the interest was 7%, and we're using the future value of an annuity. You want to see the word annuity. So where 7% meets 40 periods, we get 199.64. Slide that out of the way, and you'll see that what I'm going to enter here is the 199.64 times the payment. The payment is $2,800, and when I hit enter, I get $558,992. Okay, so that's 3 different ways that you can calculate the future value of an annuity.